State and activity diagrams. Introduction. We will discuss the following topics in this chapter: concurrent state diagrams, when to use state diagrams, decomposing an activity, dynamic concurrency, swim lanes, and when to use activity diagrams. State diagrams. In order to describe the behavior of a system, state diagrams are a helpful technique. They describe all the possible states that a particular object can get into and how the object state changes as a result of events that reach the object. State diagrams are drawn from a single class to show the lifetime behavior of a single object. This figure shows a UML state diagram for an adder in the order processing system. Diagram indicates the various states of an adder. Begin from the start point. Show an initial transition into the checking state. This transition is labeled /getFirstItem. The syntax for a transition label has three parts, all of which are optional: event, guard, and action. We have only the action getFirstItem. Once we perform that action, we enter the checking state. This state has an activity associated with it, which is indicated by a label with the syntax doActivity. The activity is called checkItem. Actions are associated with transitions. They are considered to be processes that occur quickly and are not interruptible. Activities are associated with states and can take longer. An activity may be interrupted by some event. A guard is a logical condition that will return only true or false. A guarded transition occurs only if the guard resolves to true. Sometimes cancelling an order may take place at any point before it is delivered. We could do this by drawing separate transitions from each of the checking, waiting, and dispatching states. The best alternative is to create a superstate of all three states and then draw a single transition from that. The substates simply inherit any transitions on the superstate. Concurrent state diagrams. The concurrent sections of the state diagram are places in which at any point the given order is in two different states which are totally different from one another. When the order leaves the concurrent states, it is only a single state. When a given object has set of independent behaviors, concurrent state diagrams are useful. You should not get too many concurrent sets of behaviors occurring in a single object. If you have so many complicated concurrent state diagrams for a single object, you should consider splitting the object into separate objects. An order starts off in both the checking and authorizing states. If the check payment activity of the authorizing state completes successfully first, the order will be in the checking and authorized states. If the cancel event occurs, the order will be in only the cancel state. When to use state diagrams. The behavior of an object across several use cases are well described by state diagrams. It is not applicable for describing behavior, involves a number of objects collaborating. Combining state diagrams with other techniques is a useful one. The behavior of several objects in a single use case can better be described by interaction diagrams. Activity diagrams are good at showing the general sequence of actions for several objects and use cases. Use state diagrams only for those classes that exhibit interesting behavior, where building the state diagram helps you understand what is going on. Decomposing an activity. The activity diagram combines ideas from several techniques. The event diagrams of Jim Odell, SDL state modeling techniques, workflow modeling, and Petri nets. An activity can be narrowed down into sub-activities. As a superstate and substates do on a state diagram, this works out. Either you can just show the superstate on the parent diagram, or you can show the superstate and its internal behavior inside of it. The delivery activity can be used in other contexts, the advantages of the explicit start and end states. The parent diagram is decoupled from the contents of the subsidiary diagram. dynamic concurrency. Dynamic concurrency allows you to show iterations without having to construct a loop. In the below figure, the activity fill line item is executed once for each line item on the order. The execution of the activity many times is indicated by the multiplicity marker star. When all the line items have been filled, the transition to deliver order is triggered. If several activities need to be executed together in the same manner, you can show this by making fill line item a composite activity. Swim lanes. Activity diagrams do not convey which class is responsible for which activity. In domain modeling, this doesn't mean that the diagram conveys which people or departments are responsible for each activity. Swim lanes are a way around this. Arranging your activity diagrams into vertical zones separated by lines need for using swim lanes. Each zone represents the responsibilities of a particular class. They combine the activity diagrams depiction of logic with the interaction diagrams depiction of responsibility. They are difficult to draw on a complex diagram. You need to assign activities to classes before you are done. When to use activity diagram. When to use activity diagrams. Analyzing a use case. Understanding workflow. Describing a complicated sequential algorithm. Dealing with multi-threaded application. When not to use activity diagrams. Trying to see how objects collaborate. Trying to see how an object behaves over its lifetime. Representing complex conditional logic.